I've had so many requests to do an inequalities video that I just couldn't resist. The only problem is it's an absolutely massive topic that is so hard to condense into one video, but I've given it my best go. Here are the top 10 topics that come up in inequalities, and I've done them in roughly ascending order. So if you find the first couple of topics too easy, just wait until you get on towards the end. I have used a mixture of official questions and my own questions, and that's why it's taken dozens of hours to put together. But I do it for the humble student out there. All I ask in return is that you leave a like if you liked it and a comment regardless, positive or negative. Let's do this. Just quickly to start, let's be very clear what these signs mean. Look at this type 1. That says x is less than 4. That single point or corner on the left is less than the 2 points or ends of the line on the right. That's how some people remember it. You've got one corner on the left, but 2 points on the right. And that 1 point on the left is less than the 2 points on the right. However you remember it, this symbol means less than. The symbol here means less than or equal to. So it's not just the numbers less than 4, it's also 4 itself. This means x is greater than 4, and this means x is greater or equal to 4. So if you get a question like the one above, how many integers satisfy the inequality -2 is less than x, which is less than or equal to 3, what it means is x is in between -2 and 3. But with one caveat, it could also be equal to 3. Can you quickly name all the integers in that range? It would be -1, 0, which is an integer, 1, 2, and 3. Notice how I included 3, but I didn't include -2. Now you know that, let's get straight on to the next lesson. Solving inequalities. Now for these basic inequalities, I've just taken what ETS has written in their math review so you can see the basics. After covering this, we're going to do a harder example ourselves later. So let's go through what they've written. The inequality -3x plus 5 is less than or equal to 17 can be solved as follows. First thing you'd want to do is take away 5 from both sides. You have an annoying +5 here, so get rid of it by taking away 5 from both sides. Don't divide straight away. I see many students doing that. The problem with that, if you divided by 3 or -3 straight away, you'd also have to divide the 5 by -3. Don't divide until the end, just take away 5 from both sides. That gives us -3x is less than or equal to 12. And here's the bit that so many students get wrong. To get x on its own, we have to get rid of that -3 that's in front of the x. The way to do this would be to divide both sides by -3. You could take it in 2 stages by dividing by 3 and then later dividing by -1, or you could do it immediately and just divide by -3 to both sides. But there are 2 super important things you have to remember when dividing by a negative like this. Most students only remember one of the 2 things and get it wrong. First, when you divide by a negative, the inequality will flip. Now this video is already long enough as it is, but going into a long explanation of why that is would take a bit too much time. But essentially, when you're dividing by a negative, the inequality sign flips. But second of all, when you're dividing by a negative, the other side will change sign, right? So if we divide by -3 here, not only does the less than become a greater than, but the 12 divided by -3 becomes -4, not just 4. Some students get so focused on the 12 divided by -3 equals -4 that they forget that the inequality sign flips. Other students are so focused on flipping the inequality they forget the negative and would just call it 4 here. You have to remember both. And so here we'd have the solution x is greater than or equal to minus 4. Next, we have this inequality. 4x plus 9 over 11 is less than 5. How would we solve that? First, we don't like fractions. So let's multiply both sides by 11 to get rid of that really annoying fraction. The 4x plus 9 would remain untouched. Some students attempted to times the top by 11 too. No, if you multiply both sides by 11, the only effect that you'll have on the left-hand side is getting rid of that divide by 11. The right-hand side is 5 times 11, which is 55. And now the rest is history. We can take away 9 from both sides, 4x is less than 46, and then divide by 4. No need to flip the inequality because we're not dividing or multiplying by a negative. X is less than 46 over 4, which in the GRE you'd have a calculator to solve. X is less than 11.5. I warned you that as we go through, things will get harder, and the next example combines these two concepts. What is the smallest even integer, x, that satisfies 5 minus 4x over 3 is less than 6? What's the first thing we would do? Multiply both sides by the 3, getting rid of that annoying fraction. This will give us 5 minus 4x is less than 18. At this point, we have a 5 on the left just standing alone, so let's get rid of him. And how do we get rid of that 5 that's on its own? We take away 5 from both sides, giving us negative 4x is less than 13. Just before we move on, I know a common mistake that some students would have made there. They'd have said that 5 minus 4x is just x, because 5 minus 4 is 1. No, the 5 is an integer, the 4x is a variable. They don't mix and match. You can't do 5 take away 4x is just x. No, we deal with the numbers separately. The 5 and the 18 are just simple numbers, so we just take away 5 from both sides, and the minus stays next to the 4x, so we have negative 4x is less than 13. 18 take away 5 is 13. Do you reckon you can solve this? You can pause the video, try it yourself, and see if you don't make any mistakes. Boom. X is greater than negative 3.25. We divided both sides by minus 4, so we had to remember to flip the inequality and also carry the negative sign across to the right-hand side. 13 divided by 4 you can do through long division or the calculator, and it's 3.25. So x is greater than negative 3.25. We're not actually done though. What's the answer to the question? What is the smallest even integer that satisfies that? Now, be honest, did you think it was minus 4? No, unfortunately, it would be minus 2. The integers greater than minus 3.25 are minus 2, minus 1, 0. Just think, they are to the right on the number line, which makes them greater than negative 3.25. Of all the integers to the right of negative 3.25 on the number line, the smallest even one is negative 2. Negative 2 is greater than or to the right of negative 3.25 on the number line. So we have solved this harder inequality, but we are just getting started. Here is an inequality topic that many people get wrong. If I showed most people the inequality up here in the top left, x over y is greater than 2, you know what most people would do? They would multiply both sides by y and tell me that x is bigger than 2y. But we can't do that. Why can't we do that? You can't cross multiply with an inequality if the sign is unknown. Now, we don't know if y is positive or negative. The question never stated that. And if we don't know the sign, We can't cross multiply like that. Don't forget, if y is positive, the sign would stay in this direction, greater than. But if y was a negative, and we multiply both sides by a negative, then the sign would flip, as we saw earlier on in this lesson. So because we don't know if y is positive or negative, we don't know whether to flip the sign or not, and therefore we're not allowed to do it. So it would be very tempting for many students to say A must be true. Times both sides by y, x is greater than 2y, double it, 2x is greater than 4y. But we can't say that for sure because we don't know the sign of y. What about answer C? Don't we at least know that x is positive? Because x over y is greater than 2, which is a positive. Again, no, unfortunately, because both x and y could be negative. We don't know the signs of x or y. So if we had a negative over a negative, that would cancel out to be positive, and that could still work with x not being positive. So we can't say for sure that x is positive. What about B? B we can say, because the only difference between the original and B is that they've multiplied both sides by -3. And by multiplying both sides by -3, the inequality has flipped. The 2 has become a -6, the x over y has become -3 x over y, and the sign has flipped. So this is correct, and that's perfect. I know it's super tempting to do it, but you're not allowed to multiply both sides of an inequality by a variable unless you know its sign. Of course, it's absolutely fine if they tell you that y is positive, or y is an integer above 5 or something. As long as you know the sign, positive or negative, go right ahead. But if you don't, you're not allowed. Mic drop. Time for the next amazing topic. Double inequalities. How much value are you getting from this video? If you're liking it already, please do leave a like, leave a comment, subscribe. But we are only like halfway through here. Double inequalities. This comes from my GMAT guide. If x is an integer, and if -5 is less than 3x plus 1, which is less than 10, which of the following must be true of x? And here's the secret that you can see on the screen about double inequalities. You can solve them like normal equations, as long as you remember to do the same thing to all 3 parts of the inequality. We have an annoying +1 in the middle here, so to get rid of it, you can take away 1 from all 3 corners of the inequality. The -5 would become -6, the 3x plus 1 would just become 3x, and the 10 would become 9. And again, we can now divide by 3 just to get a simple x in the middle, but we have to remember to do it to all 3 parts. -6 divided by 3 is -2, 3x divided by 3 is x, and 9 divided by 3 is 3. And you might then have just quickly clicked on answer D, but probably not if you saw that thing on the right. Don't forget, the answer choices here have an equal sign, but the answer that we worked out doesn't have an equal sign. So if we know that x is an integer, and it has to be greater than -2, then it actually starts off with -1. And again, if x is an integer and it has to be less than 3, it peaks out at 2. So actually answer A here would be correct, not answer D, because of the little lines underneath the inequalities. We are on a massive roll, so I'm going to keep going with the next inequality topic. These are gradually getting harder, so don't be embarrassed to pause the video, rewatch, rewind, keep learning. A secret here, adding inequalities. Now we're getting into things that most people don't know how to do. So if I ask you the question, A, B, and C are integers such that A is greater than D and B is less than C, what is bigger, quantity A or quantity B? Many people at this point would resort to 5 minutes of picking numbers and testing scenarios, but I have a secret for you, a secret power to imbue you with. you are allowed to add inequalities as long as the signs are facing in the same direction. We wouldn't be able to add straight away. So if we added these two inequalities, you can't get A plus B is greater than D plus C or something, because the signs are not in the same direction. But B is less than C is the same thing as C is greater than B. Or as I've written down here, X is less than Y means Y is less than X. So we can flip one of the inequalities so they're facing the same way. A is greater than D, which it was before, and now I've written C is bigger than B. And now the inequalities are facing the same direction. And because the inequalities are facing the same direction, we can now do something amazing, which is add together those two inequalities. I recently learned, actually, I probably should have known this, but you can't subtract inequalities. It's a weird thing, but you can't do it even if the signs are in the same direction. But you can add inequalities. Boom! A plus C is greater than D plus B, which is the same thing as B plus D. So quantity B is bigger than quantity A without ever testing numbers or doing anything too complicated. If you take on board this one trick alone, you can save a minute if this type of question comes up and be confident that you've got it right. I know what you're thinking. How much learning can you take in one video? But I'm going to push it even further. Positives and negatives. A very common question type. For some of you, relatively easy. For others, you always get it wrong. So I really wanted to cover it in this video. And I've written down at the bottom, most inequality questions can be solved without picking numbers. I love picking numbers for so many algebra questions, but for inequalities, I do it a bit less often. Just because often you can think about it and solve it logically without resorting to picking numbers, as we've seen so far. What about this inequality? RT is less than 0, which is less than negative R. Many of these questions, by the way, come from real ETS practice tests, so you know this is the type of question they could ask in a real test. Focus first on the inequality on the left. RT is less than 0. Now, if two things multiply to get a negative, that's how I think of it. I don't think less than 0, I think negative. Then one of them has to be negative and the other one positive. RT is less than 0 means one of the letters is positive and one is negative. We don't know which one's which, but we know one will be negative, one will be positive. What about that second inequality? It's quite hard to think about as 0 is less than minus r, but if you flip that as minus r is greater than 0, it makes it a bit easier. Minus a positive number won't be greater than 0. Minus 3 is not greater than 0. But minus a negative will be greater than 0. So r must be negative. Some whippersnappers among you will have noticed that you can add r to both sides and get 0 is greater than r, making r negative. But however you get there, that's the conclusion. We know r must be negative. But how does that help? The question's about t. We put that information from the second inequality back into the first. We know that one of r or t is negative and the other one must be positive. And if r is the negative one, t must be the positive one. And if t is positive, quantity A is bigger than quantity B. And that's the type of logic I want you to use for positive and negative kind of questions. If two things times to get a negative, one must be positive, one must be negative. If two things times to get a positive, both must be positive or both must be negative. I want you to think like that. Also, things like r squared will always be positive or 0. So think in terms of categories rather than picking numbers. Slow, big picture logic beats hasty picking of numbers in inequality situations. Let's get to the next one. Min-max inequalities. This one's a fairly lighter one, just a little interlude before we finish off with the hardest stuff. If x is an integer such that minus a is less than x, which is less than 6, and y is an integer such that minus 5 is less than y is less than 6, what is the maximum possible value of xy? A relatively common question type, and there's just a simple trick to it, and once you've seen that trick, you should never fall for the trap. If you want to, pause the video and have a go, or I'll just quickly explain. Many people would say that the maximum value of xy here would be 25. X has to be an integer, and it has to be less than 6. Y has to be an integer, and it has to be less than 6. Therefore, naturally, the biggest value of x is 5, and the biggest value of y is 5, and 5 times 5 is 25, right? What's wrong with that? That's the classic trick. As we saw before, a negative times a negative is positive. So we don't necessarily have to make both x and y positive. We could make both x and y negative and maybe get a bigger result. In this case, if we make x minus 7 and make y minus 4, which is the lowest that either x or y could be as integers, minus 7 times minus 4 is 28, which is bigger than 25. So just be careful if you get a min-max inequality question. The biggest value won't always be the positive times a positive. It could be the negative times a negative. Okay, covered min-max inequalities. The break is over. Time to go full on, powering into the next inequality topic. Quadratic inequalities. Oh my goodness. How many integers satisfy the inequality x squared plus 3x is less than 10? I would say the number of students who can get this is down to now maybe about 20% of my students. What would you do here? First thing, which I've written down below, is don't half factorize. Don't factorize the left-hand side as x brackets x plus 3 is less than 10. That does nothing. Bad student, I've written. It just doesn't achieve anything. Unless we have an equals 0 or less than 0, factorizing doesn't really accomplish much. Instead, you want to bring the 10 across and then factorize properly, factorizing everything in one go rather than just part of the equation or part of the inequality. So let's bring that 10 across. We have x squared plus 3x minus 10 is less than 0. Much nicer. I'm sure many of you know how to factorize this, but a quick recap would be we need two numbers that multiply to get minus 10 and add to get plus 3. Those two integers would be plus 5 and minus 2. They multiply to get minus 10 and add to get plus 3. So we put them alongside an x into two different brackets. X plus 5, x minus 2 is less than 0. But what do we do now? Do we just randomly test a load of integers and see which ones get us the right answer of less than 0? No, we can be a bit more strategic than that. If x was a really deep negative, like minus 100, both brackets would end up being negative. And a negative times a negative would be a positive. So x can't be too negative. X can't also be too positive. If we make x 100, then both brackets will be massively positive, and a positive times a positive would be a positive. So you can probably guess the ending. X can't be too negative, and it can't be too positive, and it can't equal minus 5 or 2, because then it would be equal to 0 and not less than 0. To cut a long story short, x has to be in between negative 5 and 2, which are the two solutions if this was an equation. X can't be at or below minus 5, nor can it be at or above 2. So x must be everything in between minus 5 and 2. Don't forget to count 0. This gives us 6 different integers that satisfy that inequality. And look, we didn't waste any time testing out a load of integers. I'll be honest, if you hadn't seen this trick, I wouldn't be too annoyed if you went through and tested loads of integers. It would take you 3-4 minutes, but it would work. But now you know the trick. Bring everything to one side, factorize, work out the two solutions, and find out what's in between. You have no excuse. I wanted to end this epic inequality video with possibly my favorite inequality question, although it also happens to be the hardest type. And again, this comes from an official ETS practice test. The question is, which of the following inequalities have at least one positive solution and at least one negative solution? Indicate all such inequalities. Now you might be looking at a couple of those and thinking, they're not too bad, I think I could probably do them. But I'm really focusing on option B and the lessons to learn from that one. But let's do them in order. What about option A? Divide both sides by x? Can't do that because again, we don't know the sign of x. So what do we do instead? I would get rid of that fraction, get rid of that divide by 3 by multiplying both sides by 3. This would give us 5x is less than 3x. Now at this point, we could take away 3x from both sides. We're not dividing by 3x, we're just taking away 3x from both sides. And because we're taking away or adding, you don't have to flip the inequality. This would give us 2x is less than 0. And now, just to be fancy, we divide both sides by 2, giving us x is less than 0. Remember, if you divide 0 by 2, it doesn't have any effect. It stays as being 0. So we know from option A that x has to be less than 0. And if x has to be less than 0, it doesn't have at least one positive solution. It has 0 positive solutions. X has to be negative. So option A is out. Time for the big daddy. Option B. X cubed is less than x. And as I've written down below, for these harder type of inequalities that seem quite stressful, another example would be x squared is less than x cubed. You have to think of 4 categories of numbers. It's not enough just to think positive and negative. You have to think of a positive integer, like 2, a positive fraction, like a half, negative fractions, like minus a half, and negative integers, like minus 2. Each type of number has different properties in these inequality questions, and so you usually have to test all of them. We can see if we can get away with only testing a couple of those categories here, but in general you want to think about all 4 types of number. So for x cubed is less than x, many people would only think about a negative integer like minus 10, or they would only think about a positive integer. But no, we are going to think about fractions too, fractions like a half. Because the thing is, when you cube or raise a half to a power like 2, 3, 4, 5, etc., the fraction actually gets smaller. So a half cubed is less than x. It is less than a half. A half cubed is 1/8, and an eighth is less than a half. When you raise a positive fraction to a positive integer power, it actually gets smaller. So a half cubed is actually less than a half. So we've found one positive solution to that inequality. But we're not going to forget the other categories of numbers. What about a negative? For example, minus 2. If we put that in, it also works. Minus 2 cubed, because it's an odd power, keeps the negative. Minus 2 cubed is minus 8, and minus 8 is indeed less than minus 2. It's further to the left, it's deeper down, it's less than minus 2. This means that minus 2 is a negative solution to the inequality. So we found a positive solution, a half, and a negative solution, minus 2, so option B is one of the valid options. And I regard option B as the hardest type of inequality to figure out. You must think about 4 categories of numbers, because each one behaves differently. Positive integers positive fractions, negative fractions, and negative integers. Here we got away with only testing positive fractions and negative integers, but in other situations you might have to test different combinations or indeed all 4 options. What about option C? That would also freak out quite a lot of people. It's just kind of sitting there staring at you like, what do we even do? And that's why I've written down below, watch out for things that can be cancelled from both sides. Even my smartest students sometimes don't notice that some things just disappear from both sides. If we take away x from both sides, we're simply left with -6 is less than -7. The x's disappear. But the lesson learned from that final option is that sometimes some things just disappear from both sides of the inequality. Now this video included 10 different topics, and you have to let me know if I pushed it too far. Was that too much learning in one video? I don't know. If you didn't think so, if you felt you learned quite a lot of stuff, or anything indeed from this video, please hit the like and leave a comment. I read them all. If there were any topics that you feel weren't covered in this video, it's probably because they bring in a different subject into inequalities, maybe absolute values, sequences, or functions. And I will cover those in separate videos. I've already done one on functions. So I can't cover literally every single way that inequalities come up because they might mix in other topics at the same time. But those are the top 10 ways in which inequalities come up. So if you can confidently master all the questions you've seen in this video, then you're well on your way to a 170. Have a wonderful day.